talk about the integrals of trigonometric functions. The very first one that we're going to discuss is the integral of sine x dx. This can be written as negative cosine x plus constant of integration. Why is that? Because the derivative of negative cosine x plus c is equal to minus the derivative of cosine has negative sign. So you have a negative sign, an extra negative sign, plus 0, which becomes sine of x, the integrand. The integral of cosine x dx is nothing but sine x plus constant of integration. Why? What's the reason behind it? Because if you take the derivative of sine x plus c, this becomes cosine x plus 0, or just cosine x, that you can just see right here. Well, let's talk about the integral of secant squared of x dx. We call the definition of secant of x if this guy was equal to 1 over cosine x. The integral of secant squared is tangent x plus constant of integration. Why is that? If you take the derivative of tangent x plus c, it's equal to secant squared. So let us take the derivative of tangent of x plus c. Remember, tangent was defined as sine over cosine. If you forget about the shortcut, write it in rational form. The derivative of sine times cosine gives you cosine squared of x minus the derivative of cosine, which is negative sine. Negative times negative gives you positive sine squared divided by the denominator squared plus the derivative of constant of integration is 0. But on the numerator, you have trig identity. This becomes 1 over cosine squared of x, or 1 over cosine x to the second power, which is nothing but secant of x to the second power. As you can see, just right here. Well, the integral of cosecant squared of x dx has a negative sign in front of it. Negative cotangent of x plus c. The same argument. The integral of secant tangent of x with respect to x is nothing but secant x plus constant of integration, and the integral of cosecant of x cotangent of x dx has a negative sign in front of it, negative cosecant of x plus constant of integration. So these are the integrals of trigonometric functions. Later on, we're going to talk about the integral of tangent and cotangent alone when we're talking about the substitution method.